Tommy?
Oh, hold on. Okay. Find the first derivative,
First derivative.
which is 3x squared minus 3.
Okay, Matt, what then do I do?
Set it equal to 0.
Set it equal to 0. Cool. Where did you find the critical numbers to be?
Plus minus.
Okay, now what do I do?
Find the second derivative.
Find the second derivative. Second derivative
6x.
test is probably 6x. Okay, cool. Now, what do I do with that? Yeah.
You plug 1 and negative 1 into the second derivative.
All right.
Negative 6 and 6.
So when I see the second derivative at 1 is 6, what kind of little picture does that paint then? The first derivative 0 and the second derivative 6 implies concave up with flat. And so from that I can say that y or f?
Y.
Okay, so read more carefully. Let's see if you would get full credit on the AP test or you said it wrong. So y has a min at x equal 1 because,
Y prime is 0 and y double prime is positive.
okay, so y prime is 0 and y double is positive. So I'm grading this, I'm an AP grader in Kansas City, grading your paper, and your conclusion is this. Y has a min at x equal 1 because y prime is 0 and y double is positive, concave up. Yes or no?
I feel like no, because you're saying.
Yeah, you just gave up the point. You were good up to there. You just said too much. You lost the point. Why?
They don't need to be.
Okay. So concave up. What is that a reference to? What's the subject of that concave up? What's the last subject in the sentence?
The double.
Yeah, you just talked about y double. You said y double is positive, concave up. Well, what's the implication? What's concave up? Y double is, there's nothing about that there. So by saying that, you're not overachieving, you're not impressing anybody. You just said too much, and you just lost the point. So say what needs to be said, nothing more. It does not help to say more. Say what needs to be said, and that's all. All right? So, y has a min at, we've got that. Y has a, I guess we need y double at negative 1, yeah? If you just did the conclusion and said the max statement without evidence, would you be good?
No.
No, you must have evidence. Y double is negative, at negative 1 is negative 6, and that's negative, so y has a max at x equal negative 1 because
Y prime is 0.
y prime is 0 and
Y double is positive. Or I mean negative.
negative. Okay, cool. Alrighty, today's lesson is pretty doggone important. It's not hard. With practice, it will get to be
That's
mastered,
what I like
but
to hear.
if you can't do USUP, then you have no chance, because it is an integral skill, all right? You've got to be able to do USUP. USUP is short for U substitution. I don't know of anybody that says U substitution, the whole thing. It's way too long. So USUP, here we go. First of all, it builds off the chain rule. So let's review the chain rule. If I take the derivative of e to the sine of x, what's the derivative?
E sine of x times sine of x.
Okay. So we can see that chain rule derivatives are products, and one factor is the derivative of the inside of the composite. So I'll give you a second to write that down. Right? When we see a chain rule derivative, you see a product and one of the little things off to the side. I know it's usually on the right, but it doesn't have to be on the right. But one little thing is the derivative of the inside of the other. Now, keep that in mind when you go to integrate something that has a product. When you see an antiderivative of a product, you should think, oh, I bet that came from the chain rule. Now, this looks like a chain rule because it's a product. And one is the derivative of the inside of the other. Now, especially for those of you who are good mental problem solvers, you could probably do this by guessing. You might be able to just tell me this, the antiderivative here is?
Negative, no,
Sine, sine
So-
x cubed, sine of x cubed.
Is the sine of x cubed. Now, that said, this is as straightforward and easy as it's going to get. And while guess and check works here, it won't work on some of the ones you'll see. So we're going to practice the use sub method on some pretty easy ones and gradually get harder. And the use sub will be there, and you'll be happy you practiced it, because there are a lot that you're going to get to that are not guess and check. For example, well, we'll see. Okay? Oh, what the heck is that? I didn't mean to do that. Okay?
Oh, I didn't see that.
We'll gradually get building up in complexity. So stick with me. Guess and check's not bad, and I don't want you to check that at the door, but you definitely need to practice the process or the algorithm. So it goes like this. Your goal is to make a substitution so you get an easier integral. You let u equal the inside of the composite function. So I'm going to say let u equal, now the composite function is the function within the function. And the function in the function is x cubed in cosine, yeah? So we're going to let u equal
X cubed.
x cubed. All right, that's the first goal. After you've decided, all right, this is a u sub problem, you choose u. Now you find the du. Here's what I mean. If u is x cubed, and I could take the derivative du dx, and it is 3x squared, I could move the dx and say that du is 3x squared dx. Now I showed that in 2 steps, but you'll do that in one. You don't need to do that in 2 steps. I just wanted you to see that it's the derivative and then separating the differentials. No big deal. You follow? Follow. All right. Now we're gonna substitute in. The integral is obviously still there. I'm not subbing for that. Cosine is still there. I'm not subbing for that. But in place of x cubed, I will substitute u. And in place of this whole thing, 3x squared dx, I put in its place du. Now the whole objective is to get an integral that's easier to work with. And I think you'll agree that's pretty stinking easy. All right? Now you need to integrate. Because it should be easier to integrate, now we can integrate. What's the antiderivative of cosine? Is it sine u or negative sine? Sine u plus c. And then, last but not least, the original problem didn't have u in it. It had x in it. So what do you reckon we got to do?
Plug in.
Yeah, you want to sub back in for u, or plug in. So your final answer is sine of, in place of u goes x cubed plus c. If you wanted to, step 6 would be check if desired. If I did a derivative on that to check, isn't it a chain rule derivative? Derivative of the outside is cosine, with the inside the same, x cubed, but then times the derivative of the inside is 3x squared. Seems to work just fine. You see what I'm saying?
Yeah.
Okay, try this one on your own or with your math amigos. Du is because I can't have an integral mixture of a little bit of u and a little bit of dx. It's got to be all x, all u. So if I just did this, then it would have been cosine of u 3x squared dx. Well, that's a freaking mess. That's not helping you at all. So anything that's sub 4, that's x-ish, has to be sub 4 completely. Everything is sub 4, not just a little. No, sorry, the labeling the steps is just for no purposes only, you don't have to.
normal problem.
She okay? Oh, okay. Are we ready? Or let's actually, let me just make sure you're getting started with, what is your U?
Natural order.
Okay, you're on the right track. Trying to make sure I'm calling everybody too. Okay, so the U is natural. What was your DU, Kendall? 1 over x dx. Okay. So when you sub, did you get a new integral of square root of u du? Okay, cool. If your integral is not easier, you did something wrong. So that should be easier. That's u to the half. So what's the antiderivative of u to the half, Harrison? Raise it by 1, 3/2, and divide by the new. I could either say over 3/2, but easier is times 2/3. Do you all agree? Okay. And then last but not least, sub back. 2/3 of what to the 3/2? Log of x to the 3/2. How'd you do? Okay. Try the next one. Yes. Do you have to show this?
Yeah.
I'm okay if you don't. I'm sorry. This one's a little funky because it kind of feels like there are two functions within a function. It looks like tangent being squared or secant being squared. So you should go further by saying really which one's the derivative of the other. Do you know your derivative rules yet?
Yep.
So which one's the derivative of the other?
Secant squared is a derivative by tangent.
Secant squared is the derivative of tangent. So does that mean you make u tangent or secant? You're going to let u be tangent, so the du is the secant squared. All right, so you should let u equal tangent.
I'm not there yet.
Okay. So, Radhika, what's your new integral? 3u squared du. Okay, do you all agree with 3u squared du?
Yeah.
What's the antiderivative? Oh, no? Okay. What's the antiderivative, Campbell? U cubed plus c, and then sub back. So did you get tangent cubed plus c?
Yes.
Okay, cool. Try the last one, and then we'll gradually get a little more difficult. It is easy. Mr. Burgess, what's your U?
Excellent.
X to the fifth. Alexandra, what's du? Okay, so this becomes sine of u du. Do you all agree?
I agree.
What's the antiderivative of sine? Cosine or negative cosine? Brian? Brian? Negative cosine of u plus c. Sub back. Did you get negative cosine of x to the fifth plus c? Yay. Okay, next thing.
Wait, Mr. Rick.
Yes, sir.
What's the point of doing the 5x to the 4th times dx?
Okay,
Like, why do we?
so everything gets subbed for, and you can't change a little of the problem to u, but keep the rest of the stuff du. So say you said u is x to the fifth, and you just sub there. So you have 5x to the fourth sine of u dx. So now what do you do? I don't know what to do either. So I mean, the reason is because you want either to go all u or all x, and a mixture of u and x is actually multivariate when you are summed. So you need to sub everything that's x in terms of this. Okay. All right. Let's try some that have a worthless coefficient. And by worthless, I mean you have to deal with it, but it doesn't affect you. If you have a number in an integral, can you bring it out front? Is that okay?
That is for sure.
Yeah. So this is the same as 7 times integral of negative sine over root cosine. Now we have a little bit of a mixture or a product. I guess you could say it's a product. It's kind of a quotient, but it's kind of a product. What's u? Yeah, the inside of the composite is the cosine within the square root. So if u is cosine, then du is sine.
dx.
Okay, so that when you substitute, you get something like the whole negative sine of x dx gets replaced by du, and the bottom cosine gets replaced by du. Okay, ready to integrate or not yet?
Wait.
Let's rewrite the power. What is this the power of?
-1/2.
You're the negative 1/2. Now let's use the power rule. When you raise to the power, divide by the new.
So it's u2, u to the 1/2.
U to the 1/2 over 1/2, or 2u to the 1/2, as the guy said. When we use the power rule, we raise it by 1 and divide by the new, but dividing by 1/2 is the same as times 2. So, your final answer? 14 cosine of 1/2, or 14 root cosine. Yay?
Plus c.
Plus c. Try the one next to it, which has a stray coefficient.
This is kind of tough. Can we bring the 4 out front?
You can. I would encourage you not to bring the 10 out front.
Man.
While you're doing that, the UNC math competition is next Tuesday. If you are good, and if you're in this class, you're probably pretty darn good at math. So if you're interested, it's first and second period next Tuesday. I know that's after a long weekend, so people can forget. But if you're interested, take this bad boy. And it has no calculus. Actually, I've seen people use calculus on it, but it's usually it's algebra through pre-calculus. Yeah. It's problem-solving problems, though. It's not like Saxony problems. It's more like thinking problems. It's really quite fun. So if you're interested, take one. If you're not interested, just pass the stack. What's your u? Negative 5x squared, so du is? Alright, so I see what I have to substitute, but the 4 is nothing I can substitute for. So I guess I'll leave the u out, the 4 out front and call it e to the u du, yeah? Do you agree? 4e to the u plus c then becomes 4e to the negative 5x squared plus c. Are we cool? Alright, gradually getting more difficult now. Okay? Look at the next problem. Sine of 3x squared times x dx. Now people then start thinking, oh, so this isn't a u sub because it feels like now, if I took the derivative of 3x squared, it should be 6x dx, yeah? But all I see is an x dx, a 6. So does that mean it's not u sub? No, it's still u sub because the x dx is what I need. It's the 6 that is a problem and we'll talk about, but we're still going to use it. So what do you want to let u equal?
3x squared.
Okay, so du is
du 6x
6x
plus c, or dx.
dx. Okay, now this is where this guy is a little different. I don't have 6x dx. I have x dx. So what do I do?
Wait.
1, 6 I heard. Move the 6. If du is 6x dx, then isn't it also true that 1/6 du is x dx? So if I want to substitute, the integral's still there, sine's still there. What do I substitute in for 3x squared? U. And what do I substitute in for x dx? 1/6 du.
Wait.
So the 1/6 can and probably should be moved out front, and you can definitely do that in one step. You don't have to show it in, then show it out. You could write it out to begin with, and that's fine. What is the antiderivative of sine? Cosine or negative cosine?
Negative cosine.
So I get negative 1/6 cosine of u plus c, and then last I substitute in for u with
3x squared
3x.
plus c.
And if it were a test and I had time, I could take a derivative to check. Okay? So you can see this is a little different in that the u or the du needs a little manipulation. Try this first one on the left on your own, and I'll be walking around. Yes?
How do you get the 1/6?
So,
What did you
do you agree with this derivative?
Yeah.
Okay? But in terms of what I have in the original problem, all I had was x dx. So I moved the 6 over to isolate what I had to substitute in for. So I divided 6 over, that's where the 1/6 came from. So after I took the derivative, I isolated x dx because that's what I had to substitute in
So
for.
you have to look at the original.
Yeah, you have to put it in the original cost. Yes, ma'am.
Oh my goodness, Tom.
Is that not? Oh, oh, dang it. I'm missing one off to the left on your notes, yeah? I'll add that in just a second. Do the 2 below it first, please. Go ahead and scratch that right one out. We're not going to do that right now. We're not there yet. Instead, do the 2 below it. Sorry. The square root of x plus 1, x plus 2, 1, scratch that. That's another use of technique that we'll do tomorrow. I'll let it right out quickly.
I know.
Marcus, what'd you use for u here? I agree. So your du is 3x squared dx. Do you all agree, people? So Alex, what'd you do about the 3 problem? Yeah. Multiply by a third or move it over, whichever you like. But you only have x squared dx in the original problem to sub for, so you need to deal with that third problem. So after substitution, did you eventually get something like 1/3, 1 over root u du?
Yep.
Excellent. What is the antiderivative of u to the negative 1/2? 2 u to the 1/2 or 2 root u, yeah? And so your final answer is 2/3 root x cubed plus 1 plus c. You win? All right. Try this last one, which really means you're integrating. You're integrating tangent there. Tangent is integrated through u, so try it.
Would it be wrong if I did do sub on cosine?
That's a great question.
That's what I did.
I will do it both ways and show you, and to answer your question, u is cosine versus u is sine. There is only one of them correct, and we will see which one it is.
It's from God.
Okay, so this is these are difficult because sine and cosine, one's the derivative of the other, so what's to say which one's the u, which one's the du? Well, if you try it both ways, you'll see that you kind of run into a problem one of the ways. So say you let u equal cosine, then isn't du negative sine? Okay, now that negative isn't a problem because I could move it over and I could say negative du is sine dx. So upon substitution, the integral and the integral is still there, and the fraction bar is still there. And in place of sine dx is negative du. And in place of cosine is u. Seems fine to me. Okay? This way, though, if you say u is sine, then du is cosine of x dx, yeah? All right, so the fraction bar is still there. You say in place of sine goes u. So is this du here?
Yes.
No, because is that a normal cosine? Okay, this is dx over cosine of x. That's what that is. Is that what you get here? No, that's not the same. Okay, and you can, as much as you want to say, oh, what difference does it make? A cosine here, dx there, one's not in the denominator? Okay, yeah, it matters. They're not the same. Furthermore, if you have a du ever in the denominator, you're pretty well screwed because you have no idea how to do that. That's differential calculus. So if you ever get a differential in the denominator, you are definitely doing it wrong. Most definitely. Okay? So this is disaster. Don't do it that way. Do it this way.
Oh.
Sine is a core u choice. Cosine is the appropriate u choice. What is the antiderivative? All right, negative natural log of cosine plus c. Now, just for the record, however, the more common form is, say you have multiple choice, and you're given this problem, and one of the choices is, this is not any of the choices. And if you look at the antiderivative of tangent, that's not it. Instead, you might see something like this. That's the correct answer. How?
Oh, because it's cosine. Wait, no.
Cosine what?
1 over cosine.
Okay, so by log rules. Log rules. Negative 1 log of cosine. If that negative 1 is brought up, that is a log rule. And what is cosine to the negative 1 power? 1 over cosine, and so it is more commonly written as log of c. Okay, log rules are a stinker. We'll get to that later. All right, That was a humdinger. Now let's just get to big, ugly ones with tons of little problems here.
That's a humdinger.
Look at, it's fine, actually, when I say humdinger, it's really not. So, you have x squared, x to the 7th plus 2 to the 50th, 4x to the 6th. Do you agree that if you had no technique and you had all the time in the world, I could actually binomial expand x to the 7th plus 2 to the 50th power? I could get 51 terms.
We have the time.
And then multiply 4x to the 6th in, and I can integrate term by term. That would be terrible. And so instead we're going to do this in a smart way. Although the 4, so I feel like u is x to the 7th plus 2, yeah?
Yeah.
Although the derivative of x to the 7th is 7x to the 6th,
It's still x to the
the
6.
fact that that's 4, not 7, is not a problem. The x to the 6th is gold. X to the 6th is the requirement, and we're good. The coefficients, I can work out the 4 and the 7, that's not a problem. If the power's not good, then you're done. You can't do it. Okay, so we're going to let u equal x to the 7th plus 2. Not just x to the 7th, just make sure u is the entire inside x to the 7th plus 2. That means du is,
7x to the 6th dx.
all right, now let's talk about that. Do you agree that I have the x to the 6th dx, but I don't have the 7th? So what should I do? Move out, I will do that in 2 steps, but do you agree that I can move the 1/7 over, or the 7 over? Okay? Now, when I go to substitute, I have x to the 7 plus 2 to the 50th becoming u to the 50th, yeah? Okay, now, what about all that stuff? The 4, did I substitute anything in for it? Oh, so it's still there. So you can either leave the 4 in or move it out front. What about the x to the 6th dx? What does it get sub for? 1/7, which I can move the 7th out front and put the dx in. Du, not dx, thank you. Du. Oh, goodness. Okay, so u to the 50th du, and that's a heck of a lot easier than the original problem. 4/7 can stay. What's the antiderivative of u to the 50th? 1/51st, u to the 51st. And then subbing back and multiplying 4 over 357. And instead of u to the 51st, it's x to the 7th plus 2 to the 51st. Don't forget your plus c. And we're done. All right. Try an ugly one on your own. Are you walking around if you're not sure what to do? Okay.
Or we go to use
Oh, chingo. Wait, so we can make the sign to the. Okay, so. And then 60. Oh, wait.
So this one's a little wacky because there's a lot of chain going on. I guess you could even say u is 2x, but making u 2x doesn't help you very much. So, pretty close. Yeah. So go bigger for your u.
Oh, okay. He that has 3 cosines, so let's get to multiply signs. Yeah, 3
See, that makes sense.
3 over 2 to the
That makes this way easier.
Hey, are we getting there?
Yeah.
Cole, did you let u equal sine of 2x?
Yes.
Okay, so what's du then?
2.
Cole. Cole, sorry. U is sine of 2x. What's du? No. What's the derivative of sine of 2x? Take the derivative of the outside. What's the derivative of sine? Cosine of 2x then times the derivative of the inside. Times 2. Okay, dx. Okay, now as far as what I have, what I don't have, I have the cosine, I have the 2x, I have the dx, but I don't have the 2, yeah? So if you move the 1/2, then I get something like this. Did you substitute u sub and get a 3/2 e to the u du? All right, excellent. So 3/2 e to the u plus c then is 3/2 e to the sine of 2x plus c. How'd you do?
Pretty good.
Okay, cool. We are getting there. Tomorrow we'll do a ton of them, but let's go to number 10. Would you pick up your calculator and get out your fun sheet? This is, 10 on the fun sheet that I handed back that we didn't finish going over. So, get out fun sheet 49. And I guess you might say, oh, we got credit up for it. Who gives a rip if I know how to do this stuff? But I would like you to actually know how to do this stuff. So, check for some mistakes and ask questions so we can actually learn from this thing, not just get points on the sheet for it, all right? So I think we did not get to 10 yesterday in this, yeah? And it's pretty gross, and it's got a calculator skill I want you to have. So we're going to use our calculator to find an inflection point of h, given that h is a terrible mess. It's a product, chains within a product within a chain. So it's a terrible thing to take the derivative of. And shoot, if I need to find an inflection point, that actually means I need to take 2 derivatives of that. That would be terrible, right? The problem is meant to be discouraging to you, not to try and do that by hand. It is not the intention that you take any derivative, not even one derivative, by hand, let alone 2. So would you start by putting the function into your graphing calculator? 5 sine of x to the 0.3 pi e to the, thanks pal, 0.3 x. I wonder if I need a multiplication there. Sometimes it's picky like that. Okay, so I get this gross graph. But thankfully, it also says shorten the window down to 0.5. So please, if they give you a window, please use it. 0, 2, 5. So it's not so overwhelmed. All right, are we all at that place or give me another minute?
Just a minute.
Okay. All right. Okay. So, we're going to have the calculator find the derivative. You follow?
Yep.
Okay, so would you go to get a new window and call it F2? Let's have the calculator find the derivative of F1. So the derivative. Did you see where I went there? I went kind of fast.
No, yeah.
Okay, so it's in the catalog menu next to the 9. The derivative button is in the second row. Where are you going? Oh, okay. Should I just take your word for it?
No.
Okay. So it's right there. You follow? Okay. Oh, I just took a second. That's not good. Okay, you with me?
Yep.
Now, what are we going to take the derivative of? F1 of x. Okay, that's cool. Now, with the calculator, I have 2 different ways to go. Do you agree to find an inflection point, I need to know where the second derivative changes sign, okay? Now, say I wanted to use the first derivative to do that. Where would I look on the first derivative to see where the second derivative changes? Max and min. Why max and min?
Because that's where the slope changes.
Okay, so the second derivative is the slope of the first derivative, right? And so if I wanted to know when the second derivative changes sign, I really want to know where the slope of the first derivative changes sign. And wouldn't that be that guy? So I could find the minimum of the first derivative there. I don't see the other extreme, and that would be the x. I could do that. What else could I do to find where the second derivative changes sign?
Take the second derivative.
Yeah, I could actually find the second derivative in my calculator. My calculator is doing all the work anyway. So let's just do in F3 the derivative of F2, which is the second derivative of F1, right? And did I not hit
I
enter?
think it's really high.
No, it's right there.
Right.
Did I not?
Mine's doing the same.
Using shuffle.
Mine's not showing up.
Maybe it's saying I don't like that.
Well, we clicked, Pat and I did it yesterday, and we did like the different button, and then we found the second derivative off of that one.
Where did you go?
So like, on the button next to the 9.
Uh-huh. Oh, you use
and
the
then
second derivative
bottom-
function?
And then the bottom left, just like click that, and then the bottom left one.
Oh, I didn't even see that. Not this one?
No,
So it's like, yeah, there is a second one there.
Did you use this one?
It's the same thing.
Did that work?
Yeah.
Okay.
You can plug in F1, yeah.
Okay, so let's try that. It's obviously having a hard time calculating slopes off of slopes. Remember, this calculator doesn't know how to take a derivative. It's all making numerical calculations, that's all. Okay, now we're talking. Does that, so this black graph represents the second derivative, do you agree? And doesn't it seem like it's changing sign right where that red guy, the first derivative, is changing slope? So that seems like it being right in line with that red min is coolio, yeah? Okay, so there's one little gotcha left that you got to be aware of. So we're going to calculate the zero on the derivative. So analyze graph, the zero, and the first thing it's going to do is say, which graph? We have 3 graphs there. You need to tell it which one, and I'm just going to click that one, yeah? I could give it a little bigger window, but or smaller window, but I'm just going to go with between 1 and 5. And you don't, so when you give it the window, you don't have to do the slider. You can just type in 1. You know that, right? Okay. You can just type in 1 for the lower bound, 5 for the upper bound, call it good. My slider doesn't work, so I don't like that anyway. Now, yeah, now that's good, but that's not the inflection point. That's the inflection x. Is that a point on the original function where it's changing concavity? No, it's changing concavity at that x, but the x on that blue graph doesn't yield a y of 0. I need to now find the y at that x. So what do I do? Yeah, I need to F1 at that. So let's store that so I can calculate that well. Can you evaluate in this graphing screen, or do you have to go to the home screen?
You can do it there.
You can? How do you evaluate it? I think there is a way to do it, but I just always go to the home
Oh,
screen.
wait, hold on.
So let's just go to the home screen, do F1 at A, and you have negative 1.137. Are we cool? Okay, so we would say F double changes sign at negative 1.137 was the Y. What was the X again? 2 something?
2.961.
Okay, something like that. You follow? That was the humdinger. Let's. There's another one?
Yeah, 4.659.
On 0 to 5?
Yeah, it's like
No.
way over there.
Oh, really?
4.659 actually.
Oh, ay, ay, ay.
Yeah, seriously.
Oh, yeah, got you. Okay, good job, good eyes. I definitely would have missed that one. And what else?
659.
4.659, what's the Y?
0.679.
679. All right, cool. go, Ms. Johnson. All right, 10, and by 10 I mean the next 10, not the first 10 we just did. Another 10. This, one of the hard parts for students is they tend to get different types of second derivative problems confused. Shoot.
Good morning, Devlin Jackwater. Please rise for the pledge of allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. All students, do you have Jaguar experience? Do you want to be on the sidelines and get in the games for free? Do you want help getting the crowd going as our mascot? TK, if you're interested in this incognito position, talk to Mrs. Sedalia.
Okay, so they say find where it's concave up and inflection. So do I need to know where the first derivative is 0 then? No, that's for extrema problem, so you don't need that.
You riches have been answered. This is the Student Voices Operation Food Fest. This year, students can participate in a fun spirit day on October 31st. Each grade has themed costumes. 7th grade will be snacks and food, 8th grade will be sports, 9th, childhood TV characters, 10th, superheroes, 11th, Disney, 12th, animals, and teachers will be monsters versus heroes. No math, prop, or fun, and make sure to keep your costumes dressed up early so you can keep it fun visit. Ha 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 ha, and see you soon. Scary salutations, Student Voice. Don't forget that you can nominate teachers for the Teacher of the Month award. Go to the Devlin homepage and click on the Teacher of the Month icon found next to the Devlin press releases section. This Friday, the Lady Jack
No.
Hey, no school? The girls will love to see you on their day off. Do you like mac and cheese? How about spicy Korean noodles? Come to Noodles and Company on
Okay.
5470 and Kibble.
We'll go over set 50 tomorrow, so you can keep 50.
Just be sure to listen to bands here. Anyone interested in participating in the UNC math competition, please talk to your math teacher. The contest will take place during first and second periods on Tuesday, October 29th. Again, please see your math teacher first.
Secant is tangent times
Go to
secant.
school on Friday. Come out and support your
Yeah.
Varsity Disco League Championship. Competition starts at 4:30 p.m.